Okay, so students, this is your aggregate impact testing apparatus. Okay. Now what we have to do? See the following. Okay. Now this is your hammer. Okay. Now after picking it up, we have to place the aggregates in this mold that is present inside. Okay. After that, we need to fix the two screw already have been fixed, and we have to give 15 blows. 1, 5. So
just a minute. There is a locking screw. If it is unlocked, then we can freely move the hammer. Okay. If it is inside this, actually for the safety purpose, we just place it here, the locking screw, so that it is not placed upon our hands or any kind of injury. We should avoid it.
Okay, so we have 15 blows. Now, after completing this, you see that whatever samples you have taken, you see the aggregate materials how it has become small. So small, that means it has been broken due to the impact or due to the sudden load. Now, we will take this sample and we will sieve it in a 2.36 mm sieve. Now, in that 2.6 mm sieve, let's see what happens.
Just a minute. Before placing the sample into the 2.36 mm IS sieve, I want to describe this is a cylindrical detachable cup which is placed inside the impact testing machine. Its diameter is 10.2 mm, 10.2 centimeter, and its depth is 5 centimeter. Okay, so now I am putting this sample in the 2.36 mm IS sieve. This is 2.36 mm IS sieve. And there is a pan to collect the residue. Now we have to shake it for 5 minutes or 10 minutes.
It is the 2.36 mm retent part. We will not use it. We are throwing it away. Now, this is the actually the passing material, or this is actually the lost material. Lost material means ड्यू टू इम्पैक्ट हमने एग्रीगेट्स कितना दिया था, ऐसा हमारा एग्रीगेट्स दिए थे, और आफ्टर द इम्पैक्ट यू सी द डस्ट फॉर्मेशन. That means actually we have taken 1022 gram of the sample, including your mold weight. Okay, now we will weight this one in this mold, and then you see the result that will be shown on the board. Okay.
আপনি তো মনে নেই তো
Now we have placed this dust on the mold. Now we will wait and you will see as a percentage that how much loss has been occurred due to that 15 dose of impact. Okay?
We have already known that weight of the empty mold is 681 gram. Now after crushing the material, we are taking the new weight including the sample as well as the mold. Yes, that is 0.732 kg, that is 732 gram. So here 732 is including with the weight of the mold, that is 681 gram. So net weight of the sample is 732 minus 681, that is your 51 gram. Now we are going to calculate the percentage passing, that is W2 means 51 divided by W1, that is 341 into 100. 51 divided by 341 into 100.
So according to the experiment and according to the result, my total percentage loss of the aggregate is 14.95%. Now just a bit recapitulation that what we did from the first. Okay, we take the aggregates, that is the aggregates of 12.5 mm pass 10 mm retent. That sample we have taken in 3 layers, tamping being done here in 3 layers, and with the weight of the mold and the sample it was 1022 grams and the weight of the mold was 681 grams. So that means amount of sample taken was your 341 grams. Okay. Now after giving the 15 blows or after giving the 15 impacts, okay, and taking that sample and then again sieving it on 2.36 mm sieve, the past material that we got, that we have placed it here and we took the weight. In that case we got the total weight of 732 grams. With actual the weight including the mold was 1022 grams. After the loss you see that there is a certain loss, it has become 732. Now your weight of the mold was 681 as before. So 732 minus 681, that is your loss was being 51 grams. Okay, now if you make a total percentage of this, your original sample was 341 grams, your loss was 51 grams. So your loss weight divided by the actual weight into 100, it gives you the 14.95%. Now 14.95% tells you, or this value actually tells you about what kind of aggregate it is. Okay. Now I am not telling you right now. After you get the manual or when you will be presenting this video in class and whenever we will be explaining it to you, we will tell you, or rather it will be better that seeing the manual, if you can tell me that this grade belongs to which category, whether it's a very good one, whether it's a very poor quality one, or whether it's a mediocre grade of aggregate. Okay, so have you understood? I hope you all understood. We will do one more sample, okay, and we will repeat this experiment once again, and after that we finish it, we will take the average of this value and then we can estimate or we can tell that what kind of aggregate it is. Okay, so students, I told you that I will be showing you the second sample, but you see that we will repeat the same procedure. Same 12.5 mm plus 10 mm return, giving the impact, then that 2.36 sieving, the same thing will be doing it here, and after that we will be taking it as an average. Okay. Now, how to take the average, that you all know. The same experiment you can see 2, 3, 4, 5 as many number of observations, and from there you have to take the average of that total percentage loss values, and then you have to conclude whether this aggregate is good or not. As an engineer in any site, you are required only to check these values. You are required to check these values and understand whether the grade of stone chip is good or poor. Okay, this comes under the section of quality control. If you ever become a quality control engineer in any site, then you have to see all those things. Now the aim of this experiment I told you, and from your side the aim is, if you don't know how to perform the experiment, then the people who are performing can make you a fool. That's a mera यही reading आ रहा है, so it's a very good thing. So you have to take one reading. If you want, then as an engineer, you can tell that okay, let me do the experiment. So that's why this is the actual need to show you the experiment. Okay? Thank you.